In this video, you will learn how to solve this UK Olympiad math question. We're asked to find the value of y. Now watch out as we are going to use some logical tactics in solving this question. Don't forget to give this video a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified Olympiad math solution. Now to get started, I want you to remember something. That in solving this question, we want to assume that negative 8 can be equal to negative 6 minus 2, right? Minus 6 minus 2 is going to give us a negative 8. So what we are going to simply do is to replace that with what? Negative 8. So we're going to have this equation to now give us y minus 6 all to the power of 4 plus y minus 8 all to the power of 4, and this will be equal to 16. So if we insert minus 6 and minus 4, we're going to have this to become y minus 6 all to the power of 4 plus y minus 6 minus 2 and all to the power of 4, that will be equal to 16. Great. So if we simplify this, we're going to see that we have one unique thing, that we have negative 6 and negative 6, which are common. So what does that tell us? From this expression now, I can let my p to be equal to y minus 6, because we have y minus 6 to be common. If we do that, we're going to simplify this expression and we'll find it easier to play with. We have p to the power of 4 over here, and this is going to give us what? P, which is y minus 6 minus 2 all to the power of 4, and this will be equal to 16. Great. Now let's simplify this further. If we simplify this further, we are going to find the value of p. Now recall that we have 4, and 4 over here can be equal to 2 multiplied by 2. So if we look at that expression, we're going to have our p to the power of 4 plus we'll have our p minus 2 all to the power of 2 multiplied by 2, and this will be equal to 16. Now recall the law in indices that if you have a to the power of xy, this can be equal to a to the power of x multiplied by y. If we apply that expression here, this whole solution will give us the value of p squared, right, plus this is now going to give us a full bracket of p minus 2 all squared, and all of these will be what? Squared, and this will be equal to 16. Now let's look for a way to expand this. If we expand that by factorization, we are going to have that expression to now be p to the power of 4, right? This is p to the power of 4 and not 2, right? P to the power of 4 plus, let's expand that. If we expand that, we're going to have this value to become p squared, right, minus 4p, right, plus 4, and this will be all squared, and this will be equal to 16. Great. Now, come to look at this. We're still going to look at an algebraic expression to simplify this. Now, let's assume this to be a value where we'll take this to be something like this. So if we use this algebraic expression, we're going to simplify this. So let's look at this algebraic expression. If we have this whole thing square, it's like we having a plus b plus c, or what? all squared. What will this algebraic expression give us? It will give us a square, right, plus b square, right, plus c square, right. This is going to give us plus 2 times the first a and b, plus 2 times b and c, plus 2 times c and what? A. Great. Now from this expression, you come to see that your A is equal to P square, right? And our B is equal to negative 4P, right? And then our C is equal to what? 4. Now let's insert that into that expression. If we do that, we'll have P to the power of 4, right? Plus this whole expression will now give us, we have to be careful about this so as not to make mistake. We'll have P square, which is A square, right? Plus we'll have B square, which is going to be negative 4P, right? All squared. And then we'll have plus c square is going to give us 4 square, right? Good. And this is going to give us plus 2 multiplied by a is going to be p square, right, multiplied by b, which is equal to negative 4p, and this will be plus 2 multiplied by b, which is equal to negative 4p, right, multiplied by c, which is equal to 4, and this will be plus 2 multiplied by c, which is equal to 4, multiplied by a, which is equal to p what square, and all these will be equal to 16. Great. Now let's simplify. To simplify further, we're going to have this expression to now give us p to the power of 4, right, plus this is going to give us p to the power of 4, right, this whole expression, plus this is going to give us 4 bracket square is going to give us 16, so we'll have 16p square, and this will give us plus this is going to give us 16, plus this is going to give us 4 times 2 is 8. That will give us negative what? That will give us negative p, negative 8 what? 8p to the power of 3, right? Because 2 times negative 4 is going to give us negative 8, and p squared times p is going to give us p to the power of 3, and this will give us plus 2 times 4 is 8, 8 times 4 is going to give us 32, so that will give us negative 32 plus 2 times 2 will give us 8, and that will give us what? 8 what? 8p square, and this will be equal to 16. Great. Now we're going to simplify this further. To simplify this further, we're going to now have this expression to become, this is going to give us 2p to the power of 4, right? And that will be equal, that will be plus, this is going to be 16p square, right? And this is going to be plus 16 minus 8p cube minus 32p plus 8p square, and this is equal to 16. Now let's subtract 16 from both sides. To subtract 16 from both sides, we're going to subtract 16 from here. The right hand side is going to give us 0. So we subtract 16 from this side, we're now going to have 2p to the power of 4, right, plus 16 p squared, right, minus 8p cubed minus 32p plus 8p squared equal to 0. So let's simplify further by factorizing. If we simplify further by factorization, you'll come to see that plus 6p squared will add this, and the whole solution will give us 2p to the power of 4. Arranging them in order, we'll have 8 to the power, a p to the power of 3, and this is going to give us a positive 24p squared, right? And this is going to give us negative 32p, and this will be equal to 0. Now we're going to simplify this. Looking at this expression, you'll find out that something is common, and that is what? 2p. So we're going to bring out the first 2p, and when we divide this whole thing by 2p, you find out that we'll have the value of p to the power of 3 remaining here, right? Because if you multiply this by this, we're going to have p to the power of 3, and this will be negative 4 divided by 8 divided by 2 is going to give us 4 to the power of p to the power of 2, right? And this will give us 24 plus 24 divided by 2 is going to give us 12p, right? Minus 32 divided by 2p is going to give us 16, while this all will be equal to 0. So what do we have here? We have what we call the product zero product rule. So from the zero product equation, we can see that we can bring out two cases. The first case, we have that 2p will be equal to 0, and case 2, we find out that p to the power of 3 minus 4p squared plus 12p minus 16 will be equal to 0. Great. One linear, one sum, one polynomial. So what we need to do is to solve the linear. To solve the linear, you find out that we'll have to divide both sides by 2. If we divide both sides by 2, our p will be equal to 0. So you find out that if we insert this value into the expression we are given for the value of what p equal to y minus 6, we're going to have an undefined solution. So the next is the polynomial equation. So we're going to test or solve this polynomial equation by using the normal polynomial method. We're going to insert the value first of p equal to 1 to find out if p equal to 1 is a solution. The first one is going to give us 1 cube, which is 1, 4 plus 12 minus 16. Is this going to give us 0? If it does, that means p equal to 1 is the first root we'll have. So if we simplify this, we're going to have this to be equal to, right? 1 minus 4 is going to give us a negative 3. Negative 3 plus 16, 12 minus 16 is going to give us a negative 4. A negative 4, negative 3 is going to give us negative 7. So this is not a root of that polynomial. Now let's try p equal to 2. We try p equal to 2. What do we have? We're going to have this to give us 2 to the power of 3 minus 4 multiplied by 2 square, right, plus 12 multiplied by 2 minus 16. Will it give us 0? Let's test it out. If we substitute that, we're going to have 2 to the power of 3. 2 to the power of 3 is going to give us 8, right? So this will give us 8. 8 minus 2 square is going to give us 4. 4 times 4 is going to give us 16 plus this is going to give us 24 minus 16. Now 8 minus 16 is going to give us a negative 8 plus 24 minus 16 is going to give us a positive 8. So this is equal to 0. So that means the value of p equal to 2, which can be equal to p minus 2 equal to 0, is one of the roots of that polynomial equation. So what do we need to do from here? We're going to simply use the first root we've gotten to do what? To find the other two roots. Now, given the original polynomial, we're going to divide this value with the original polynomial. The original polynomial we are given is, we have the original polynomial to be p to the power of 3, right, minus 4p squared, right, plus 12p, right, minus 16, and that was equal to 0. So we're going to multiply it with p minus 2. Now, if we multiply this with, or divide this with p minus 2, we're going to have this expression to now give us what? This expression, 3p cubed divided by p, is going to give us p squared, right? P squared times p is going to give us p to the power of 3, right? While p squared times negative 2 is going to give us negative 2p squared. So if we subtract this, we're going to have this expression to now be equal to, this is going to give us 0, while this minus this is going to give us minus 4p squared plus 2p squared is going to give us a negative 2p squared, right? And we'll be left with what? With plus 12p minus 16. Great. Now, minus p squared divided by p is going to give us a negative 2p, right? So, negative 2p minus negative 2p multiplied by p is going to give us negative 2p squared, right? Negative 2 multiplied by 2p multiplied by negative 2 is going to give me a positive what? 4p. So if we subtract this, that result is going to give me, this is going to give me 0, while this is going to give me positive 8p, right? 12 minus 8, I'll be left with negative 16. So the next step we'll take is 8p divided by p is going to make that value to give us a positive what? 8, right? And 8 times p is going to give us what? 8p minus 8 times 2, negative 2 is going to give us negative 16. So if we subtract this, we're going to have this to become 0 and what? 0. So what does that tell us? That tells us that the quadratic equation we have for that solution is equal to, the quadratic equation is p squared minus 2p plus 8 equal to 0. So we are going to solve this quadratic equation in order to find the other two roots. But before we solve this quadratic equation, let's first of all find out if the solution to this quadratic equation is going to give us imaginary solutions or real solution. So let's get to find the discriminant of this equation, and that will be what? B squared minus 4ac. From that expression, we are going to see that b squared is equal to b square is equal to our discriminant will be equal to -2 square, right? And then we'll have -4 multiplied by 1, which is a, multiplied by 8, which is c. To do this, we're going to have this to be equal to 4 minus 32, right? So our discriminant will be equal to 4 minus 32 is equal to, our discriminant will be equal to -28. And you find that our -28 is what? Is less than what? 0. So what does that tells us? That tells us that solutions that will come from the solution of this quadratic equation is going to give us imaginary solution. So there is no need of solving this question, this quadratic equation, because we're not going to use them. So as a result of this, we're going to neglect this solution. So the value of p we've gotten so far is equal to 0 and what? And 2. From that, we can see that the value of p is 0 and 2. From our original equation, we are not asked to find the value of p, we are asked to find the value of from the original equation we are given the value of y. So we initially made our y, our p, to be equal to y minus 6. So if we have that expression p equal to y minus 6, we can simply find the value of y for those two expressions. The value of p is equal to 0. So from the first expression, if p is equal to 0, then we'll have p equal to y minus 6. So that will give us 0 equal to y minus 6. So the value of y will be equal to, if we add y to both sides, the value of y will be equal to 6. That's the first solution to that equation. Now the second solution, we are meant to find out that our p is equal to 2. So if our p is equal to 2, we have our p to be equal to y minus 6, right? So our 2 will be equal to y minus 6. If we add 6 to both sides, we'll have our y to be equal to 2 plus 6, and our y will be equal to 8. Great. So the value of y is equal to 6 and what? And 8. These are the solution to that expression that is given to what? Given to us above here. Now let's check to find out if the solution to this question is absolutely right. To do that, we are going to check by substituting the value of y equal to 6 into the original equation. We have y equal to 6. Let's substitute it to find out if we'll get the right hand side to be equal to the left hand side. If we do that, that means our solution is perfectly right. Now from the original expression, we are given that the value of y minus 6 to the power of 4, right, plus the value of y minus 8 to the power of 4 is equal to 16, right? So if we insert the value of y equal to 6, are we going to get that original? Are we going to have the left hand side to be equal to the right hand side? Let's check that out. So we're going to have on this side, we're going to have the value of 6 minus 6, right, all to the power of 4, plus over here we'll have our 6 minus 8 all to the value of 4 to be equal to 16. This is going to be 0 to the power of 4 plus, while this is going to give us -2 to the power of 4. Is it going to give us 16? Let's find out. This is going to be 0, while this is going to be what? 16. So you see 16 equal to 16. That tells us the value of y equal to 6 is a perfect solution to that equation. Now let's find out for the value of y equal to 8. For the value of y equal to 8, we have this to become 8 minus 6 all to the power of 4, right? Plus 8 minus 8 all to the power of 4. Is it going to give us 16? Let's find out. 8 minus 6 is going to give us 2 to the power of 4 plus 8 minus 8 is 0 to the power of 4. And 0 to the power of anything is 0. So we'll have 2 to the power of 4 to be equal to 16. So that means 16 is equal to 16, which shows us that the value y equal to 8 is another solution that satisfies that exponential equation that is given to us. Okay. These are the solution to that equation that is given to us. I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified mathematics solutions. Thanks so much for watching, and bye bye for now.